Okay.
Okay, define and define inverse functions. First of all, what is an inverse? What does that word mean?
Opposite of reverse.
Opposite, sort of, yeah? Okay. So we're going to run with a super mild idea that inverse kind of means reverse. Okay. In math, can you give me an example of things that are inverses of one another?
Minus and plus.
Minus and plus, right? Perfect.
Okay.
So we go minus and plus, plus and minus, divide. Yep. Anything else?
Divided and times.
Right, times divide.
Root and square.
Root and square, nice. So I'm going to write that's something to the power of and root. Beautiful. So those are your major ones. There's other things as well. What we're going to write. If that's a function, then this is its inverse function.
That makes sense.
Okay? Right. Because if you raise something to the power of -1, you get 1 over that thing, so it's like dividing by. Beautiful, yes, that's fine. Cool, alright. Well, we're going to think about this. We'll systematise this later. But for now, we're going to think about this in a general sense, and then we'll narrow it down a bit better. Okay. I've got x plus 3. What do you reckon its inverse probably is? X minus 3 seems to make a bit of sense, right? Okay, well let's have a stab. Don't write this down just yet. And make sure that actually works. Yeah, that's fine. Cool. That does turn out to be true. Okay, great. Let's go with this guy. What would you assume this thing's inverse function was?
X on 4.
X divided by 4. That seems reasonable. And what would we assume this thing's reverse was? Sorry, inverse was?
Square root.
Right, square root x seems to make a bit of sense. Okay, fine. Looking at that, is it obvious what that thing's inverse is?
2.
Plus 2.
X plus 2.
Wait, where's... I've got to have square root. So where's the square root go?
Oh.
So it seems like I need a square root and a plus. But does the plus go after the square root or in the square root?
Oh, it goes in the square root, doesn't it?
It goes in the square root? Okay, why?
Plus 2 first and then the square root. Or is that Don't just go up on there.
Right. Yep.
Got to go after because you're inversing each individual value.
Okay, so we could argue this either way, yeah? So we'll leave this one for now. We'll try to systematise what we're doing here, and then we'll expand it to the less trivial case. Okay. Great. Well, let's think about what these two things look like. Cool. X plus 3, what does that guy look like?
X and a second.
Why don't I do this in red? I should have done it in red. No, I'll do that. No, that's fine. Cool. So X plus 3, what does it look like? Okay, a line. Good. We narrow that down slightly. What kind of line? A linear line. So a straight line? Yep. Anywhere in particular? Where's it run through?
Y is 3.
Right, y is 3. So y-intercept of 3 and
X equals -3.
x negative 3. Cool. So we get negative 3 is 0, 0, 3. Something nice and boring like that. Cool. Does that look straight? Not the best, but that works. Cool. Alright, x minus 3, where's that go?
Oh.
Through Y minus 3.
Yep. And
Plus 3.
right. There's you. That is right. There-ish. Cool. 0. Okay, great. Alright, cool. Well, that's interesting. They're parallel. Maybe that's useful. They've gone through a lot of 3s, but then it says 3 in the rule, so maybe that's not that surprising. Okay. Let's draw up these pair. that straight?
Nope.
No. Try that again. Second best.
But it is better. We're making progress.
No, that's going to do for now. It's pretty straightforward thing. Cool, alright. 4x, what's that going to look like? Y equals 4x, what does it look like?
Oh,
What's that?
x equals,
For
X equals zero.
once we got how to deal with basic straight lines.
x equals.
Right, the straight lines.
The origin.
Right, straight through the origin, right? Because plus c is plus 0. Doesn't go anywhere. What does the 4 do?
Just divide 0 divided by 4.
0 divided by 4.
Sorry, that's to get the x-intercept, so x is 0.
Changes
It's the
Right,
gradient.
changes the gradient, right? The 4 is the gradient. If it's 4, what does it look like? Roughly, super rough.
Steep.
Right, steep. Yeah? Go. We're not too happy with that. Let's try it again.
It's more of a cubic than anything.
Cool, alright. Red one. X on 4, what's that going to look like?
Same thing.
The same thing.
Oh, no, just
Same thing but less steep. Okay, just like a little bit less steep or
By a lot less.
by a lot less steep? Okay. Can you tell me what it's going to look like with reference to this?
an if.
It's going to rotate clockwise
It's going to rotate clockwise
from
through.
the origin.
Okay. Let's- Something like that.
Yeah.
Cool.
Yeah,
Okay. Is there something that you could measure on this graph to tell if I've done it adequately? It's a bit of an odd question. Is there something that should be the same?
0.
Okay, yeah, it goes through the origin, true. Something else about the entire line rather than just
the
the
distance from the axis.
distance from the axis, okay? Instead of distance, I'm going to say angle. This angle and this angle should be the same, yeah?
Oh, yeah.
Yeah, because this one's going up 4 and across 1, this one's going across 4 and up 1.
Oh,
Yeah, so that angle should be the same. Yeah. Cool, beautiful. Alright, fine. Next guy. Terrible, start again. Beautiful. Okay, x squared looks like
parabola.
parabola, which looks like. Alright, nice smiley face, beautiful. Okay,
A little bit extra on the
not
left.
exactly symmetric. Let's get that off. No, halfway between each. No. How's that? Alright.
It is better.
Beautiful, so there's my x squared. Okay, root x, what does that look like?
Isn't it like what's it called?
Is it flatter?
It's a root graph.
Oh no, it's
Truncus.
never mind. Yeah.
Cool, so it looks something like that. Yeah?
Yes.
Okay.
Well, wouldn't the inverse be the plus and the minus?
Very good, Aaron. Okay, so for this, right, what's the reverse of square?
Oh,
Square root, whenever you take the square root,
plus minus.
plus minus on there. That's why
So
there's a little bit of a gap here, I was
parabola.
waiting for someone to say it. Excellent, cool, so this would be the plus branch. Where's the minus branch go?
I don't know that.
Right underneath. Beautiful. That was terrible. No, not terrible, but actually, yeah, a little bit. Cool. Ugh, that's anything nice. It'll do. Okay. Cool. Okie dokie. Anyone want to hazard a guess? What makes an inverse an inverse? Graphically. What's happening between red to black or black to red? Rotating is pretty good. Rotating where? about the origin in, we're getting there. Is there some pattern going on here?
Yes.
Yes, no, I don't know, maybe there isn't, maybe you can't say it, I don't know.
Potentially.
There's some sort of rotation going on, right?
Are they flipping the X and the
Well, not in the first one.
Not on the first one though. Right, so it must not be a rotation then. Maybe it's reflections,
Is it flip?
right? Flipping,
Is it
reflections.
flipping like? Oh shucks. Never mind.
How do I get from this black line to this red line?
Oh, you just move the thing.
Jump.
You
Okay,
switch
I
over
could
the X and
slide
Y.
it across, but if I'm doing a reflection, where's the mirror for the reflection?
Oh, it's down, what would be x equals y.
Right, I'd have to do a mirror over there. Yeah? Okay. What if I put the mirror here? Does that work?
Yeah.
Yeah, right? That one flips to there, that one flips up there. What if I do it on this? Does that work?
Yeah.
Also, yes.
Yeah. Right, so this branch will flip to that branch, this branch will flip to that branch.
Bless you.
Right? So an inverse you can think of as being a flip across y equals x.
Well, can the reflection change?
Can the
Reflection change.
can the reflection change?
So
You
like
mean
now it's.
reflected around something else?
Yeah.
You can reflect things around other things, but they won't be the inverses.
Oh, okay.
There'll be a relationship between them, but they won't be inverses. Yeah, we won't do that in Maths though, because inverses have other properties that we actually want to exploit. Beautiful. So this whole thing ends up being flip across y equals x. And by flip I mean reflect, but it's just a flip across. Yep.
Is that kind of just like the basic rule for inverses, or is there special like?
So that's the intuitive graphical interpretation.
Yeah.
Right?
Okay, in simple terms, will the mirror change in rotation?
As in the position of the y equals x line?
Yeah.
No. So that the mirror for a reflection is always y equals x. Always, always, always. Beautiful. Great, good. Okay. So now we ask some mildly annoying questions. Okay. I'm going to take this point and reflect it across the mirror. Well, that would mean that it lands about there.
Yes.
Yeah? Cool, okay. I could take that point, reflect it across, it'll end up about there. Yeah, we're okay with that? Cool. Take that point, it'll end up reflecting about there. Okay, fine. Let's consider another point that might make it a bit easier to see what's going on. What if I take that? Where's that going to reflect to?
0, -3.
Okay. Let's pick a point on this. Point 1, 4. Okay, so I'm going to pick the point 1, 4. Where's the point 1, 4 going to reflect to?
4, 1.
4, 1, right? Just makes sense. Cool. And if I pick some point down here somewhere, right? Let's call that -2, 4. Where's that going to reflect to?
4, -2.
2 or -2. What have you done just implicitly? Switch the x and the y around. Why does that make sense?
Because you're flipping them.
Okay, so because it does, right? So, when you're flipping it over, you're literally reflecting one and then reflecting the other. So it's always going to be that you've just flipped x and y. Another way of thinking of it is you just exchange those, you swap. Okay? Well, that's convenient. say what we're doing, we're going to flip x with y. Alright, so that I'm thinking of as y. So now that's x, and now this is y. Oops. Brilliant. Do we know how to graph that?
No.
No, right, we haven't seen y squared turn up. Other than, well, we've seen y squared once. Where have we seen y squared turn up before? Circles, right? But that was only when x was squared as well, so this isn't a circle, we know it's
Oh,
going to be a circle anyway.
would I make it go on the side?
Yeah.
So, so it'll look,
Like that.
yeah.
Right? Something like that anyway.
And then-
So sorry, what am I saying? Sorry, right. Yeah.
Because then there'll be two y's instead of 1, 2 x's, is it?
Depends what else happens. But okay, let's follow it through. Okay, to draw functions, I usually want y by itself. So we'll move stuff around. Okay, so I've got x plus 2 equals y squared. And then I can take square root of this. Alright, and someone should tell me there's a problem.
Plus or minus?
Right, I need plus or minus on it. Now at this point, is this a function? No, why?
Because because for one x value you can have two y values.
Perfect. Alright, if I sub in 1 or something for this, I get the square root of 3, but I get positive and negative square root of 3. I put in 1x and I got multiple y's. This is not a function. Well, that sucks. Maybe there's a way of representing this relation as multiple functions. Alright, almost as though we do things in order for a reason. Cool, so I want both of those things. Okay, fine. Now, this isn't actually going to be a function, it's going to be a relation, but I can represent it as two functions. Beautiful. Well, what does that thing look like? Let's draw these up and try to have this to scale. We're going to need 4. Oops. Ooh, we tight. Yep. When you're doing these generally, you don't need to do to scale, but since we're doing this for the first time, it helps if it's to scale so that you get an idea of what's going on. Your intuition can kick in a bit better. Cool. Not the best ever, but that'll do. Okay, x squared minus 2, what does that look like?
Oh, it just looks like negative 2.
Y is negative 2.
Right, it's a slightly lower parabola. Right, x squared, that's parabola, minus 2, shut it down by 2. Great. So we're going to go through there. If we put in 1, we're going to get there. If we put in 2, we're going to get there. Cool, and that's going to go off.
Nice. Nice.
Something like that. Is that symmetric? Oh, jeez, I didn't even draw this vertical. Ooh.
Wait, so was that all you do for the inverse?
That's all. Sorry, say again.
For the x minus 2. So so the inverse of x squared minus 2 is that square root of x plus 2 and minus x plus 2.
Yeah. So the inverse of this is these.
Okay.
Of that one or these two, depending on which way you want to write it. Cool, alright. Square root of x plus 2, what does that look like? Let's try that again.
It'll be a truncus, wouldn't it?
No, not a truncus. It'd be the one with the sharp point.
The what? Oh, yeah. What's it called? Oh, root graph.
Root graph, right, okay, so it's a root graph. What does the 2 do?
It just moves it up.
Shifts it to the left.
Yeah.
Right, this is under the root, so it's going to shift to the, and it's b, so it's going to shift left by 2. Cool. So we end up starting there. Root graph. Go there, 1, 2, 3, 4. Gonna go through. Beautiful. Okay. Am I done?
No.
No, what else have I got to draw?
Minus.
Negative one, right? Which is just the same thing flipped over. So we'll go through there. There should be more curve. Something like that. Beautiful. So, let's check our intuition. We'll draw in that. Does that look like it's flipped across that line?
Yes.
Yeah.
Yeah.
Right.
No.
Yes, no.
Well, what about the bottom one?
Okay, when you say that bottom one, what is that?
For the parabola, for the x squared minus 2 one, if you flip that one over on
This?
Yeah.
I'm going to flip it over this
Oh,
thing.
change, never mind. That's
Yeah,
it.
so that point flips to there.
Yeah.
This arm becomes that arm. This arm becomes that arm.
Okay. Makes sense.
Okay. Beautiful. Okay. So as soon as if we look at that, we go, yeah, no, that lined up pretty well. We're pretty happy that that's worked. Because generally, if you make a mistake, it'll just wander off somewhere and then it'll look totally wrong. Great. Okay. Well, let's go back here for a second. Oh, even better. Let's go back here. Is there anything more interesting on that graph that I should label?
20 points? Oh, which one?
On this?
Oh, no.
How many points are straight lines?
Yeah.
No, that's it. I've got all my intercepts and line steps. Great. Here, I should label 0, 0. Anything else?
That's
No,
it.
they only intersect there. They don't do anything else special. All right. What about this guy?
Intercept 0, 0.
Okay, they intersect 0, 0.
What about when the parabolas cross over? Would you-
Right, we need where they cross over. Where are they going to cross over? Okay, oh, no, yes. Okay, interesting. All right, well, when things are crossing over, that means that their rules are equal. Yeah? Okay, so we need when rule 1 equals rule 2. Now, technically there's a plus minus on this, but we can rule that out because we already
It's in
know
a
it
positive.
has to be in the positive. Alright? You could run with the plus minus, it'll just make life a bit more difficult to go for a bit. So usually, when you're doing your algorithm, pick one or the other for this, and then you figure out which one you need pretty quickly thereafter. Okay. How am I going to solve this? Any suggestions? Say again. Throw numbers at, okay, throwing numbers at it, in this case it will actually work, but in general, it won't. So we want an actual algebraic solution. What's complicated about it?
Well, there's a square and a square root.
Right, there's a square and a square root. Which one are you more afraid of?
The square root.
Square roots, right? Because that gives you irrationals and they suck. So how do you get rid of square root?
Square.
Square everything. Right, alright, so this is x to the 4 equals x. Okay?
So it's 1.
Right, it is going to be 1. How can we solve this though? How do you
Chuck 1
solve
at it.
Say again.
Chuck 1 at it.
So, so yeah, I've given you a nice easy one to start so that we know where we should end up. Right, because we're about to do it with that, which is not going to be as straightforward. Right? So instead, I'm looking at this and I go, oh, that's annoying. I've got a power of 4,
Oh, damn it, wrong one.
so that's a polynomial. What's the first thing you do when you've solved any polynomial?
Remember.
Pardon?
Factorize it?
So we want to factorise it.
Okay.
What was your
Right.
question?
First thing you do in quadratics and everything.
Simplify for something.
If I gave you that, what's the first thing you're going to do?
I translate.
When you say translate?
Like move everything to one side.
Yeah, move everything to one side. Cool, is everything on one
No, us.
side?
No.
Which one would you rather move?
The x.
The single x, right? Because you don't want a negative in front of the largest term.
Oh, and then it gives you.
You get that? Okay. I want to factorise this. How can you factorise it?
Can you make
Divide by x.
Right, everything's got an x in common, so take out a common factor of x. Okay, x cubed minus 1, well that's a difference of 2 cubes, if we remember that.
Oh lol, have we done that?
We did it, but like, oops, okay.
I don't even remember the
Okay, we'll
formula.
write out the difference of 2 cubes. So if you've got a cubed minus b cubed, let's see how good my memory is today. A minus b, a squared, plus minus.
Yeah, sounds right.
I don't know if that's right or not. What do we get? 2 a squared. I am not at all convinced that might be a plus.
This is case. My bet it's a minus.
Can you just divide with when you have an x?
Yeah.
Can you just divide both by x then and then remove the half of the
So, yes, you have to be careful. Alright, so
Pretty sure it is a negative.
let's do that as well. As a side note.
Can you do sub x into capital X? So sub x squared into capital X.
Okay, if you do that, then this is now the square root of capital X.
Will that make it harder?
Because you've just gone back to this.
Oh, true. J.
Yes. Okay. I'll do it this way first and then I'll do that as well. Because you can do that, you just have to be careful. You've taken the shortcut, and as always, if it's called a shortcut, there's a reason.
Yeah.
It works perfectly fine. You just have to be careful.
Yeah, that's right.
What are the difference to cubes? Three. I think I got that right. I think. Yep. Go. Beautiful. Alright. Cool. Alright, so for us, A is going to be X, B is going to be 1. We're all happy about that? Yep. So X minus 1, X squared minus 2X plus 1.
Are we supposed to learn on the cube formula?
This thing, so it comes up so rarely that it's not really worthwhile. I would definitely have this written somewhere in your book somewhere so that you can, in the few times where it does come up, you can go, oh, got it. Right? It's almost certainly never going to turn up in exam 1. It could, in theory it could, but,
Can you tell us if it does?
sorry,
Can you tell us if it does?
can I tell you if it does? I can't tell you what's on the exam before I've seen it. Like I'm talking about end of year 12 exams.
Ah,
Right, so I can't remember a time where this has turned up in the exam 1. In exam 2, you get to take in a bound reference.
yeah.
So if it does, that's fine. You've got it in your bound reference anyway, and you've got your CAS as well. So you just go and factor it for me, thanks. Yeah, so I wouldn't pull your hair out trying to memorise that at all, because there's the sum of 2 cubes as well. So I wouldn't pull my hair out worrying about that. Yeah, but if you know it, great. It's just an extra tool in your toolbox to nail stuff out when you need it. Cool. All right, this thing equals 0. Great. This is okay. This is okay. What's this?
Is that a squared or a cube? A squared.
Negative 1 x.
That's an a squared. Is that what you're talking about?
No, in the first line. Is that x squared or x cubed?
X squared.
Okay.
Squared.
It's
Cool. All right, we're happy with this. All right, because that'll give us a solution. We're happy with this. That'll give us a solution. This we're not so happy about.
it's just x negative 1, x negative 1.
Right, complete the square on it.
Just x minus 1 cube.
In fact, we'll run
Complete
the
square.
square bracket.
You mean
X
recognition?
minus 1 squared. Oh, it's just x minus 1 twice.
Yeah, that's it.
So that's it.
Oh, you can you can use recognition.
Oh yeah, you can use recognition as well. Good.
Yeah, yeah.
So I've got
Just
that.
yes.
Brilliant. Okay. So therefore, x equals 0 or 1. Cool. Well, that's unsurprising. We figured out 0, and because we said it a million times before, x could also be 1. Cool. If x is 1, what's y?
1.
Also 1. squared is 1 squared, great, or you can go
Oh,
down
and
square
it's
root of
what
1,
got
also
the.
1.
Oh, yeah.
Cool. Beautiful, done. Done, okay. Great, great, good. That's done, that's done. So
Wait. How'd you get 1 for 1?
I get 1 for
Just
y.
sub in
So
one for
we know that the x value is 1, yeah.
Yeah.
Put it back into the rule. 1 squared, still 1. So, okay. Because this is on the black line, yeah?
Yeah.
Right. Alternately, you put it into the red one because it's also on the red line. Square root of 1, 1.
Could you also sub in 0 from x?
Right, yep. And then put in 0 into
Oh,
these and you get 0, 0. So we've got that one as well.
Okay.
So we get that and that. We can get algebraically. Alternately, you can just look at it and go, oh, it's 0 and 1. Done.
Yeah.
That's fine. There's nothing wrong with that. If you can inspect it and just go, oh, it's this, fine. For this one, you might be a bit more hard pressed to spot some. You can spot some though, but we'll leave that spotting for now.
I feel like there's a lot of intercepts there.
Right, there's a whole bunch of stuff going on, yeah? Right. So, how do we find, oh, first of all, we should try to label off some stuff.
X intercepts and Y intercepts.
Right, x and y intercepts, this guy,
-2.
0, -2. This guy,
√2, 0. -√2, 0.
Negative 0.
1, 2, -2.
Oh, oh, sorry, I thought you were talking about the black.
Oh, yeah,
Yeah,
sorry, yeah, I was just talking about this. Okay,
sorry.
Cool. Alright, going in there.
-√2, 0.
Negative root 2, negative root 2, 0. Oh, negative.
Like that's it.
Negative root 2, yeah. Okay, so, is anyone lost on where